All right, I'm going to try modeling some bioreactor data today using Claude Code. In a previous video, we used Emacs and gptel as an interactive notebook, and Claude Code is more of a command line tool. And so we're going to try that today. So welcome to the Emacs channel, and we're going to see Claude in action here. So we'll start here. I have a basically empty directory except for this bioreactor CSV file. We can just look at this. It's a bunch of numbers. Maybe we should look at the head and see that there is time, X and S. X is the biomass, S is the substrate composition, and our aim is to explore this data, look at it, etc. And we're going to do that through a terminal, unlike a Jupyter Notebook or Emacs this time. So to use Claude, you have to have it installed. You have to have either an account or set it up with API. I've already done that, so I just open it by running Claude, and then we have a new interface to work on. So let's say I'm going to tell it to read the CSV file in this directory, and I don't have to be very specific. There's only one. You may want to tell it a specific one if there were lots of them, but for now we just tell it. It finds the right one, well, the only one, and you can see it reads it. It contains bioreactor experimental data. It's probably inferred that from the name of the file. Maybe it's inferred that from here that this is biomass, this is substrate. It gives you some basic ideas of what's happening. Let's say, let's plot the data. So it kind of tells you what it's doing. It's going to create a Python script, and then it asks, here's what the script looks like. And then it's going to ask me, do I want to proceed? Just press 1 for yes, and it pops up this data, which you might remember if you saw the previous video. We see substrate going down, biomass going up. Looks pretty good. All right, now I want to model this data. Suggest 2 models. I don't know exactly what models would be best for it that might fit the data. If you know a specific model, you certainly can specify it. But the point here is to see how little can we say. All right, so this gives me a classic mechanistic model and an empirical model. All right, they recommend that they start with monad, and if it doesn't, try the logistic model. All right, let's just fit both of them. Fit both models and tell me which one is better and why. This is pretty typical of working with Claude. You tell it something, it thinks, it does some little stuff, sends you some idea of tokens. If you have the regular Claude, like $20 a month, there are some limits on how long you can run it before it says you have to take a break for usually like 5 or 6 hours. If you pay for one of the Max subscriptions, it's either 100 or 200 a month, then you get either 5 times that limit or 20 times that limit. So let's see what we have here. We have model 1, model 2. All right, let's just let it go. This is not a very complicated fitting problem. Sometimes it makes sense and pays off to tell Claude to generate a plan, stepwise plan, before it runs anything, and then you can tell it to execute each step of the plan. As the tasks get more and more complicated, it is better and better to do that. This case, I think we're going to get away without doing too much of that. So it is making some figures. It's interesting, it's trying to read the image. Let's see, if I type Control O, it kind of gives you more detail of what it's doing. Okay, let's see what we get here. So we have a little report. The verdict is that the monad model is better. Better is, it has a better R squared for both substrate and biomass. It has a higher AIC, or maybe more negative AIC. And so monad is the winner, like all around, but logistics not actually that bad, probably. It gives us key findings. Let me see. Open the comparison figure. Let's have a look. Since it's executing commands on my computer, it usually asks for permission. Let's see, here is the comparison. So you can see the blue line is monad. It goes through the data better, where logistic is overestimating here, underestimating here, and it's not too great. The residuals are a little bit worse for and a little less random for the logistic model than the monad model. These are still not mean zero, probably. You see a little bit of deviation, but most people would be pretty happy, I think, with this. Okay, and then let's do one final thing, write a summary report as a PDF so that I have some record of something that's been done. And let's see, it's basically made two figures in here, that's all. That's the only artifact that is in there. Maybe if we do ls-al, you can see there's a .claude. So there, you may be able to, if you got skilled with Claude, why don't we just look in there? It just has some settings. I'm curious what they are. This is a place where you can, this is just keeping track of permissions. That's not super interesting. In that directory, you can create or add specialized tools, specialized skills, other things that control how Claude works. All right, let's just go ahead and make it. So this is using Python to generate a PDF. And let's go ahead and open it. So we get our bioreactor modeling report, and it gives me an executive summary saying the monad outperforms it, a little introduction, here's some experimental data, there's the figure, that's nice, and then here are the two models that it says that it used. Here are, oh, that's not so beautiful, it's got some HTML things that don't look great, and then our summary figure, some discussion, the conclusions, that all looks pretty nice. Let's ask it to document the Python scripts that were used so we can review them later. I'm not sure I'd say that's publication ready and suitable. Certainly, I mean, it's a PDF. You could ask for it in Markdown. We could have had it Let's see if we can get it to make the report as a docx. Let's just save that as a docx and make a PowerPoint presentation of the key results. Alright, so coming back here, we now have some Python script. Here's our PDF file that was created. Okay, so it's thinking, it's trying to finish the scripts, and then it will create those. So being able to save these file artifacts is probably helpful, because later you'll wonder how was it made, and depending on things, I guess that there's not a transcript that's getting saved with Claude Code here. Maybe somebody knows how to make that happen, but I'm not positive. You can also integrate this with version control. So if we wanted all of this to be saved as different versions in a Git repo, that's a way you can iterate over time. And even though Claude Code is advertised as a coding tool, we are writing code to do this analysis, but it is doing more than just writing and running code. It is doing analysis, it's making figures, and it's actually running commands for you, for better or worse. There are security implications associated with running arbitrary shell commands, arbitrary things. And there could be privacy IP concerns about sending this data. This data is going to Anthropic. That's what Claude Code uses. You could, if you preferred, use docx. That's the OpenAI version. Maybe you have ChatGPT for education or some other version where you have a little bit more say on what happens to the data. Or Gemini CLI might also be a possibility here if it's connected to a subscription that has where you have an agreement through your company or university that they don't use the data for training. But it's kind of a decision you have to make. There's not a Claude Code or Codex or Gemini that uses a totally local LLM like one of the Ollama models, and those are much slower than this. So it looks like we're using Python to generate a docx. The only reason I want the docx is you can edit it. So if you don't like something or you want to fix something, it's much easier to edit and fix than the PDF. And how's it making a PowerPoint? It's probably doing the same thing. There is a PowerPoint Python file too. Let's see what we have. Open bioreactor. You can see here we have now a nice Word document. Has sort of the same stuff. These actually came out nicer. A blank page that needs to be, maybe you want to get rid of. And there's that. All right. And then let's look at less fit models. This has the Python code that presumably you could run manually now. And Let's say this is using, again, another Python script to generate PowerPoint. Seems okay. And this went ahead and opened it for me. So you have to do a little bit of work here. This is off screen. That's not okay. And it uses this old 3x4 format. So, it's clearly not perfect, but this is not too bad. Maybe there's some prompting you could do in here to fix that now that you know that it is a particular problem. All right, that covers most of what I thought would be interesting, just to see whether or not we can use Claude Code for data analysis and fitting models and doing things. I like some things about this quite a bit better than using the Emacs gptel integration. Mostly this automatically links and integrates with other programs on your computer and can automatically run them for you. As long as you are okay with that idea and are able and willing to either trust it or read it and review it and decide that it's worth doing. There's lots of ways that you can manage that. You can have it generate the code and then you run the code. With Emacs, I had it generate code and then I ran the code as well. But it was a little bit more explicit in how I did it than having to come over here and say, let's look at less plot data and kind of scroll through this and see there's nothing mean looking in there, so we could just go ahead and run that. So that's the idea of today's video, is just looking at this command line user interface compared to the previous notebook interface. And this is the first time I've ever tried doing that, so certainly there are lots of things to be learned. There are lots of ways you might customize Claude Code to document each step, to put work into version control, to create README documents so that it's easy to follow, the logic and whatnot. But that's going to take some thinking and time to try out different ideas and see what works well. All right, that's it. Thanks for watching. See you next time.